Hey everyone, my name is Quinn Kuslich and I'm a professional VR developer and Unreal Engine expert. In this UE5 VR tutorial, we'll be adding an advanced thumbstick locomotion system to the VR pawn. But we're not stopping there. We're going to replicate the movement system from Half-Life Alyx, which in my opinion is the best feeling locomotion system in any VR game that I've played. By the end of this video, you'll have thumbstick locomotion, sprint functionality with a stamina cooldown, and a jump system that directly recreates the mechanic from the game. I think this tutorial is especially valuable because you will not only gain VR development skills, but you'll also learn how to create complex shaders and basic particle effects. Before we get started in this video, I feel like I need to drop a quick disclaimer. I'm going to be kind of changing outfits and facial hair throughout this video, and that's because I had to reshoot part of it. When I originally uploaded this video, I was accused by another creator of plagiarism. And at the time, I took it very seriously, and I made sure to go and watch their entire video. And upon watching their video, I learned that the function that I used was very similar to their function, and it's because I used their blog post originally to put my code together. However, this code was using universal nodes from Unreal, meaning that no one can really own them. And when it comes to thumbstick locomotion, there's only 3 ways that you can really code the very specific kind of code that they claimed that I stole from them. Despite disagreeing with them, I did not want to be at odds with another creator in this community. That's not what I want for the VR community on YouTube. So I took my video down. Despite not wanting to, despite it definitely hurting my revenue, and also, kind of making my audience really confused. It was frustrating for me. But I did it anyway, and I went and I recoded the entire function in a different way, so therefore there could be no question that this code was mine. And I want to say I would not have been able to do it without the help of a creator by the name of Andrew Yemitz, who is actually a YouTuber who owns the company Head Mounted Software and makes a plugin called the Head Mounted plugin, which is actually on the Epic Games Store and you can go download it. I would really recommend going and checking out his channel and the video that he made regarding thumbstick locomotion, because he explained kind of what the function was. He gave his opinion and kind of like a universal ideal that you can't really own code like this, and then he went and published the files for free so that anyone could create this. And then he said that I could remake my tutorial using his code, which was really awesome of him. So the code that I've used actually dates all the way back to 2017, and as far as I'm concerned, no one can own this code. It is not a product that you can claim ownership of, and that is how code works in Unreal. So if this matches anyone else's tutorial, that is purely coincidental because this is the way that you code this. That's my final word on it. And I just want to make a promise to everyone watching my videos. I will never come after you if you use my code. So let's say that I create this thumbstick tutorial, and then you want to add some other functionality to it, but you need to use mine as a base. So you make your system, and you use my thumbstick code as a base. I will not come after you. You can go ahead and sell it or do whatever you want with it, but I will not come after you because that is not the type of community I want here on YouTube. I just want to make my stance clear on that. If anyone disagrees and wants to do it a different way, that's fine. They can do their thing. I don't want to yuck their yum. My channel is meant to be a place of collaboration, and it's been that way since I started it. Just like with all my other VR development lessons, the code for this tutorial is available on Gumroad. If you would like to skip the video and just get the code, you can now download it for $10. The reason that the price is increased is because I felt this was a more reasonable price for the work that I put into it, as well as the fact that I will not be undercutting anyone else who is selling a similar product. So now that I've gotten that out of the way, let's get into the tutorial and let's do some thumbstick locomotion. Before we begin, there's 2 things I want to mention. The first is that we're going to be using Unreal Engine 5.4 for this tutorial. The other thing I want to mention is that I have already plugged in and set up my Quest 3 for Unreal development. If you're not sure how to set up your headset for development or even download the engine and start a project, I want you to go and watch my absolute beginner's tutorial first before you do this one. It's going to help you get the headset set up for Unreal development and also get Unreal set up so you can develop stuff on your headset. There's a link in the description to that video that you can follow right now and get started, and then you can come right back here when you're done and get to the thumbstick locomotion. But with all that said, let's open Unreal Engine and get into the video. We're going to create a vanilla VR project. So I want you to go to Games and then Virtual Reality, and we don't want starter content. We're going to pick a good project location to save our file, and we're going to call this project Thumbstick Locomotion. While we're waiting for Unreal to open, this would be a great time to subscribe to my channel. I've got a bunch of awesome VR tutorials that I've already made and a bunch new ones coming, especially from my Half-Life Alyx and Unreal Engine series. Alright, so now we have a fresh VR project that we can wreak havoc in. Let's see what functionality we have available to us. To launch a VR project in Editor, you're going to go to this little hamburger menu in the upper left, and you're going to click VR Preview. Right now, we do not have thumbstick locomotion. We have hands, we rotate on the left stick, and then we teleport by pushing forward on the right stick. We're gonna actually kind of change these things around and make our own locomotion system built on top of this original system. So we're gonna kind of take some of this code and we're gonna move some other code around to fit our purposes. So let's get started with that. The first thing that we need to do is create a bunch of input mappings for our new thumbstick locomotion system. We're gonna be using the new enhanced input system that comes with Unreal Engine 5.3 and up. Actually, it might just be 5.0. In the past, we were able to make input actions directly inside of the project settings, but now we make them inside of the content browser. It's like they're assets themselves. I'm unsure why we switched over to this system. I know that there's benefits to it, and I haven't really looked into it. The only thing that I did was learn how to use it, but when it comes to how it works and why we switched to this system, I'm completely unsure. But I do know how to make new input actions, so that's what we're gonna do. So we're gonna navigate to the lower left-hand corner of the screen, and we're gonna go to this content section. Then we're gonna go to the VR template folder, and then inside of that, we're gonna go to input. This is where we're gonna put our input actions. The first thing I want you to do is open up this actions folder, and then we have a few different actions that we need to add. Let's get into how we actually create an input action. We're gonna go into the content browser here. We're gonna right click, and then we're gonna type input action. And we wanna select this one with the little game controller right here. And we're gonna call this one IA move horizontal. We're gonna click into that. And in the action description, we wanna put locum like thumbstick. The reason that we add a description to every single one of these actions is so that we can ensure that they actually work when we try to call them in the VR pod. There's something up with this enhanced input action system right now, whereas if some of the input actions share the same descriptors or they're all blank, some of them might not fire off at all and they won't work. So therefore we'd like do all of our code and then we'd launch our project and try and test it out, and we'd push the thumbstick forward and nothing would happen and we'd get no feedback from the controller. I don't know why it's like that, but adding a description has seemed to fix that for me in the past, so that's what we're gonna do for every single one of these that we create. Another important thing to consider when creating new input actions is actually what type of value we're assigning to them. So by default, all of these input actions start with a value type of a digital bool, and that means, you know, it is either on or it is off. For the move horizontal, it actually is gonna need to be some sort of axis so we can tell how far we're actually pushing our controller joystick forward or backwards, right? Except for this case, it's horizontal, so it'd be left, right. We need to give it, you know, an axis value so it understands, you know, how far to go when we're pushing it. Basically, it controls the speed of our character when we're strafing or moving forward and backwards. So in that case, we take this value type and we change it from digital bool to an axis 1D float. And that gives it that axis so we know where our inputs are sitting when we're trying to move our character. And then we're going to just save that and make our next thing. So we can go ahead and close our input move horizontal, and then we want to create another one, which will be our vertical movement. So we're going to go and we're going to create another input action. So type in input action, select that game controller again, call this IA underscore move vertical. And then we're gonna click into this one as well. And for the move vertical, this is also going to be a axis 1D because it's, you know, a joystick. We're using a joystick and its movement. So both of our movement vertical and movement horizontal need to be joystick actions. And for this action description, we're gonna do thumbstick movement. It doesn't actually really matter what you put in here. It just needs to not match the existing move functionality that we have. So that's move horizontal and move vertical. And we can add our next input action. So we're going to right click again. We're going to type input action. So our next one is going to be called IA and then underscore jump. And this one's actually a little bit more interesting because we need to do some special coding inside of here to make it work. Essentially, the way that it works in Half-Life Alyx is if we're going to jump, we actually pull back on the right stick, and that creates like a teleport arc like we see in this project. And we're gonna add some, you know, VFX and shaders to that later, but for now we have to code kind of how it works. Currently, the way it works in the project is if you push the joystick forward, the teleporting functionality appears and you get that arc and that little circle that's on the ground, and we need to make it so it's the opposite. Instead, you have to pull back on the stick in order to jump forward, because that's how they programmed it in Half-Life Alyx, and we want to match that for this tutorial. So this is optional. You can actually just keep it as is, but if you want to match Half-Life Alyx, this is the way to do it. So we're going to go into our IA jump, and the first thing we're going to do is we're going to change it from a digital bool to a axis 1D float. And then we're going to go down to modifiers right here where it says modifiers, and we're going to click twice. We're going to create 2 new modifiers. The first one is going to be called dead zone, and that's going to look like this. And then the next thing we need to do is actually save this, and we're going to dock it up here in the right. We're going to go back to the VR template. We're going to go to content browser, and we need to find a very specific function. So if we're sitting inside of the input action mappings right now, we actually need to go back to the input folder. So we just click on the little input button that takes us back, and you'll see this little enhance input action modifier class blueprint. It's a blueprint, and it's a blueprint of a very specific class that kind of modifies how a controller or how a input action actually functions. We need to write our own custom code inside of one of these to make it work. So what we're going to do is we're going to take this B input modifier x-axis positive only. We're going to actually duplicate this, and we're going to call this one B input axis negative only. That way we can swap it and pull back on the stick. We're actually going to open this up because we need to change some logic inside of here. So we're going to go to this modify raw function. We're going to double click it, and that's going to actually open up the function that's making this happen. And we need to add our own custom code in here to change it so it works for our purposes. And that change actually happens right here in the clamp float. As you can see, it's got a minimum and a maximum of 0 and 1. In the direct center of this controller, minimum would be 0, right? Or like the direct center would be 0. If we pushed it forward, its maximum would be 1. And if we pulled it back, its minimum would be -1. So we need to change this so it's not saying, you know, minimum is 0. It actually needs to be minimum is -1 and maximum is 0. That way this input action only fires if you're pulling back on the stick, not pushing forward, which is how it's currently coded. So what we're going to do is we're going to go into the clamp float where it says minimum. We're going to change that to -1, and then we're going to change the max value to, we basically make it so instead of pushing the joystick forward, you're pulling it back, and that's going to activate the function. Now we go back to our IA jump functionality, and we're going to go down to our modifier section again, and where it says index 1, we want to open that menu up, and we'll see the brand new input modifier that we made just now. And we're going to add that. So it's B underscore input modifier x-axis negative only. One more thing to note when setting up our jump input action is we need to change the dead zone lower threshold from 0.02 to 0.7. It'll keep us from accidentally triggering it when we're trying to snap turn on the same joystick. And that finishes up our jump input action. So now we can file, save all, just to make sure everything's saved, and we're going to go back to our input actions, and we're going to add our other input actions. For our next input action, we're actually going to just straight up edit one of the ones that already exists. So we're going to right click on this one that says IA turn, and we're going to change it to IA underscore snap turn. And then we're going to open that up, and we need to go down to this dead zone here, and we change the dead zone to 0.8. The final input action we need to create for this would be our sprint functionality. So we're going to right click, we're going to type input action, and we're going to go IA underscore sprint. And we're going to click inside of here. We're going to ensure that it is a digital bool because that's what we want it to be. And then we're going to say sprint thumbstick. So now we've created our input actions, but what we need to do is actually give them buttons to make them work. So we take the input actions that we just created, and then we assign them to buttons on our controller. Note that if you are not doing this tutorial with the MetaQuest 3, your buttons will be different from mine, so you can't really follow them. You're going to have to figure that out yourself. If you are on any sort of Meta headset, you can follow the same button mappings that I'm using, and it'll work just fine. To assign buttons, to add our input mappings into a player controller class. So in order to assign buttons that we can then use to trigger our actions, our input actions, we're gonna need to add them to a input action data asset. And we luckily already have one created for us. It's this IMC underscore default. So what we're gonna do is we're gonna double click and open that up. And then in the left corner here, you'll see mappings. And if you expand that, you'll see the mappings that we've already added. And that gives us a good idea of what's currently there. And we can add our own actions in right on top of these. Another thing to note too is that there are some of these that we actually have to remove entirely. So what we're gonna do first is we're gonna go over to the IA move and we're gonna click the trash can symbol to get rid of it. And then we're gonna replace that with our IA move vertical and IA move horizontal. So to create a new input mapping, we're gonna go to the mappings and we're gonna click the plus button. And then right here, we're gonna type in IA _ move horizontal. And then it's important that we assign the right thumbstick access to this controller. So for IA move horizontal, we're looking for the Oculus Touch left thumbstick X axis. So on this little keyboard right here, you're gonna click the none box. You're gonna type in Oculus Touch left thumbstick X axis. So left thumbstick X axis right here. Okay, so that's our move horizontal done. You can save that, and then we can click plus to add another mapping, and then this one will be our move vertical. So we'll type move vertical, and that'll pull up our input action asset. We'll click that, and then we'll expand this arrow so we can add its binding. And this is Oculus Touch left thumbstick Y axis. So just so you guys know, the reason that we're doing this is right and left would be X axis on this joystick. Up and down would be Y axis. So to move forward, we're on the Y axis, and to move left and right, we're on the X axis. That's why we're doing that. So we'll type in Oculus Touch left thumbstick, and we're looking for Y axis for the move vertical. And then we can save that and close those two. Then we're going to add our sprint functionality. So this will be IA _ sprint. It'll pull up the data asset that we already created. We're gonna open that up. And this one, the way that I want sprint to work is when we're pushing forward on the left axis, we are actually gonna push in on the sprint button. And if we push in and hold it down, that'll cause us to sprint. So we're looking for left thumbstick button specifically. So we're gonna do Oculus Touch left thumbstick, and then we're looking for button, left thumbstick button. Cool. Finally, we are going to add our jump functionality. So the reason that we removed that move functionality is because we're replacing it with our jump functionality with our updated, negative axis stuff. We're gonna click plus to add another mapping. We're gonna go down to IA _ jump. And for jump, we're looking for specifically the Oculus Touch right thumbstick Y axis. So make sure this is the right thumbstick and not the left thumbstick, or it'll disable both our vertical move and our jump. So Oculus Touch R Y axis. There it is right there. Cool. So that is all of our input mappings put into our IMC default. Now we can start programming the logic in our VR pawn. Before we start coding any functionality for our Thumbstick Locomotion, we need to make sure that the input actions we just created in the IMC default actually work. So we're gonna test that. We're gonna go to the content, and then we're gonna go to the VR template, and then we're gonna go to the blueprints folder. Inside here, we're gonna open up the VR pawn. We're gonna drag that up and we're gonna dock it up here. And what we need to do is grab one of our input actions and see if it fires. So I'm gonna do our IA _ thumbstick, IA move horizontal. I think that's a good one to start with. We're gonna drag off of the triggered, and we're gonna call a print string. And essentially what this will do is it'll just keep looping as long as we're pushing the trigger to the right. So I'm gonna go ahead and type in I'm working. I'm gonna compile and save that. And then I'm gonna go back to the VR template map and I'm gonna launch. And I believe I mapped the move horizontal to my left controller. So I'm just gonna pull. That is totally working exactly as it should. I don't know if you noticed when we were just testing that. The good news is that when we triggered the input, it did work. The bad news is that it was also triggering our snap turn, which I don't want to be on the left hand, I want it to be on the right. So we need to go into the IMC default and locate the IA snap turn. From there, where it says Oculus Touch left thumbstick x-axis, we need to change that to Oculus Touch right thumbstick x-axis. That way we're rotating with the right stick instead of the left stick. We're gonna find that right here at the very top. It says IA snap term. We're gonna go down to where it says Oculus Touch left thumbstick x-axis, and we're gonna go Oculus Touch thumbstick right thumbstick right thumbstick x-axis. There you go. So that should fix that. So we'll go back and we'll run our project again. So now if we push the thumbstick left, we should see the print string coming up, and we're also not rotating because we're actually rotating on the right hand instead, which is exactly what we want. Now that we've confirmed that our input actions are working and we've fixed, the few bugs that we had so far, we can go into our VRPON and start coding our thumbstick locomotion logic. So we're gonna go into our VRPON, which is located in the VR template, blueprints, VRPON. I already have it open, but you just double click to open it up. And inside of here, we're going to actually take this enhanced input action IA move horizontal, and we're gonna delete it for now because there's other functionality we need to code first. So inside of the VRPON, the first thing we need to do is actually in the viewport. We need to change the VRPON from a actual pawn class to a character class. That way we get access to something called the character movement component, which has all of the code we need to actually make our character move around in space and do other things like jump and set the actual speed of how fast the character moves and pretty much everything else. It's what the first person and third person character blueprints use in the other templates, and the VRPON just doesn't have one because it's a pawn. It's essentially a camera with hands. We need to give it a capsule and also the logic it needs to move around. So the way that we do that is we go to class settings, and where it says class options in the upper right corner, you'll see the parent class currently is pawn. We need to change that to character. So we're gonna click on that drop down, we're gonna type character, and we wanna do just the regular character. And what you'll notice is what that does is it adds this capsule to our scene. And now we have a few issues that we need to fix right now, otherwise it's gonna not work at all. So now that we've added a capsule component to our scene, what we need to do is take everything that's like inside of our VRPON and actually move it to the floor so it like kind of parents to the capsule. So what we're gonna do is we're gonna click on our VR origin, and we're gonna go over to the right here, and on the transform, on the Z axis, we're gonna type -90. And what that does is it sets our character at the bottom where it's supposed to be. And now we need to actually change the size and height of the capsule so it better matches our real world height, kind of how tall we want to be in the scene. So what we're going to do, we're going to click and we're going to open our capsule component. So essentially go to the components tab to the left here. We're going to click capsule, and you'll see capsule half height and capsule radius. So the capsule half height is the overall height of the capsule, and this also determines how tall we're going to be as the character. And then the other one is the capsule radius. This determines like how big the capsule is around, and that affects, how we collide with things when we're moving around the VR world. So what we need to do is change these values to be a little bit better. The height we can leave as is, it's fine, but we do need to change the radius to 15, and then we can compile and save that as is. So we've set our capsule to the correct width, and we've also set our VR origin to the right height on the capsule. It's time to create some logic that actually takes the capsule and updates the position based off where we're looking and standing in the real world. That way, if I try to like physically walk through a wall, I can't, because as the camera updates its position, so does the capsule. We're also gonna add in some brief functionality to that to give it a little bit of leeway. So if I want to lean over a table or do something else, that I'm allowed to do. To get started, I want you to go to the VRPON, which is located right here in the content browser, and double click to open that. And then we're going to navigate over to the event graph, where we're going to create some custom events that's going to allow us to set the capsule position to match the camera position. So to get started, we're going to go down here right underneath where the event begin play track kind of ends. And we're going to right click in the graph anywhere, and we're going to do add custom event. And we're going to call this event update capsule position and rotation. So the first thing we need to do is go to the left-hand side in the components panel. We're going to grab the capsule component right here. And then we're going to go down to where it says camera. We're going to drag out a reference to that as well. These are the two things that we need to align. You can press Shift A to get them to kind of line up here. Now we're going to drag off from the camera, and we're going to do get world location. And you can press Q on your keyboard to align these. We're going to do the same thing for the capsule component. So just grab this get world location, Control C, and then Control V right below it, and then connect that up to the capsule component. Now what we need to do is we need to take the world location of, what we need to do is subtract the capsule component world location from the camera world component location. So what we're going to do is we're going to drag out from the get world location on the top, and we're going to do a minus, and that's going to pull up a subtract node. And so the A should be connected to the camera get world location. We're going to connect the B to the capsule component get world location. Now, right on this pin, we're going to right click on that, and we're going to do promote to variable. And then this one is going to be called, oh, well, I dragged it all the way over there by accident. I'm going to drag it right back here. We're going to call this one camera offset. And then make sure that we set this to our Thumbstick Locomotion category. So we're just going to either type in Thumbstick Locomotion, or it will already be typed in, I can't remember. And that'll be located right here on the left, and that's what we want. So we're going to take that, and we're going to grab our update capsule position and rotation. We're going to drag that over, and we're going to set that into our event. Now, we're going to drag off. We're going to drag off from our setter for the camera offset. We're going to do add actor world offset. And what we need to do is drag out from our camera offset. We're going to type a break vector. And then we're going to click on the delta location of our add actor world offset. We're going to split the struct pin. And then we want to connect the X and the Y from our break vector up to our add actor world offset. Then what we need to do is drag out a reference to our VR origin, drag off of that, and we're going to type add world offset. This is just for our component. And we're going to connect these two, and then we're going to grab this delta location. We're going to split it again. And then we're going to drag off of our camera offset, and we're going to do a multiply. And we're going to drag this out like this. We're going to right click on the bottom of the B pin of this. We're going to right click on the B pin of this multiply vector, and we're going to change it to a float. So just do 2 float, single precision. And we actually want this to be multiplied by -1. So it should look like this coming down from the camera offset, and that's multiplying by -1. And we're going to right click, we're going to split the struct pin coming off of here. And we're going to connect the X up to the X of the add world offset, and the Y up to the Y of the add world offset. And that is code that is setting the position and rotation to match where our camera is pointing. And we're going to actually link this up to our Thumbstick Locomotion code as soon as we're done with our height function, which is right below. So we're going to go right below the event we just created. We're going to right click in the graph, and we're going to do add custom event. And then this one is going to be set capsule height. This is going to actually set the height of the capsule to match our camera, so if we're like crouching beneath something, it will follow us and not get us stuck on things. So what we need to do is we need to get a reference to our capsule component in the components tab. We're going to drag out of the capsule component, we're going to do set capsule half height. And that's going to pull up a node that allows us to actually set the half height. And then what we're going to do is we're going to right click on this, we're going to do promote to a variable, and then this one will be called capsule half height. Also, for the capsule half height, we want to set its default value to 88. And then we want to make sure that update overlaps is checked as well. Okay, so we're setting the capsule half height with the capsule half height variable that we just created. So now we actually have to take code that we can, use to populate the variable, because 88 is not the function that we want. So what we're going to do is we're going to drag out a reference to our camera, and then we're going to drag out a reference to our VR origin. And we're going to drag out from the camera, we're going to do get world location. Then we're going to drag out from the VR origin, we're going to do get world, well, actually, no, we can just take this and copy paste it beneath, because we need the world location of both of these. So we've got the world location of the camera and the world location of the VR origin. And what we're going to do is we're going to pull out, we're going to do subtract. We're going to connect these two like so. And then we're actually going to drag this up, and we're going to split the struct pin coming off of our Z. And we're going to use, and then we're going to pull off of the Z, and we want to divide this by 2. And then we want to add 5 to this. And what we're going to do is drag out, and we're going to do set capsule half height. And this is our variable that we created. And we plug that into the set capsule half height node. So we're basically setting it from the camera and the VR origin, and that sets our height properly. Now we want to drag out a reference to our VR origin from the components tab, put it right here. So we're going to drag out from our VR origin, we're going to do add relative location. We're going to connect that up to our set capsule half height. We're going to split the delta location struct pin, and then we're actually going to drag off from our add 5. We're going to do a subtract. We're actually going to break that struct pin by clicking Alt, and then we're going to drag out a reference to our capsule half height. We're going to put that into the A of our subtract, and we're going to pull out from our +5 again and put that into the B of our subtract, and then we connect that up to our Z pin, and we leave X and Y completely blank. So this function is now setting the height of our capsule correctly, but we need something to actually, make it happen. So what we're going to do is we're going to drag this up just a little bit, and we're going to go over to the top of our graph here. And what we're going to do is we're going to add an event tick. So just go event tick and drag that in. And then I want you to drag out from the event tick and do set capsule height. We're going to be setting the location to match our player height, so how we're standing. So we're just going to drag around this entire piece of code that we've just created, and then this is going to be sets the position, rotation, and height of the player capsule. Okay, so we've got code for getting our player capsule to actually work, but we need to link it in so that when we push on the controller, it actually moves forward. So what we're going to do is we're going to go down beneath the code we've just created, and we're going to create input action. So what we're going to do is input. What we're going to do is go right below the code that we just created for setting the location and rotation of our pawn. And we're going to right click, and we're going to do IA move vertical. And remember, these are the input actions we created earlier. And then just below it, we're going to do IA underscore move horizontal. And then we're going to drag out from the move vertical, and we're going to do update capsule position. And make sure you're dragging out from the trigger of this node. Capsule position and rotation. Basically, so every time that we push the joystick, it'll kind of work like an event tick where it will fire every frame that we're pushing the joystick. But it only does it when we're actually trying to move. Otherwise, it would be doing it constantly. So if we tried to lean over a table or lean around a door frame, it would actually just kind of cause our character to spaz out or teleport on top of the table. So this code allows it to only fire when we are pushing the joystick. And that's why we're doing it this way instead of just connecting it up to the event tick like our set capsule height. So go ahead and drag off of the set capsule position and rotation and do add movement input. This is coming directly from our player capsule, and it just, is code that's included in there that makes it work. So what we're going to do is we're going to drag out a reference to our camera, because remember, this thumbstick locomotion system is based off of our camera direction. So what we're going to do is we're going to drag off, and we're going to do get forward vector. And so we're taking our camera, we're firing a line out from it, and wherever that arrow is pointing, that's where we want to move. That's the direction we want to move. And then for the scale value of the movement input, we're just going to connect up our action value right here, like so. Okay, and then for the move horizontal, we're going to kind of do the same thing. So just copy paste everything we have here and then drag it down below. And I want you to connect up the move horizontal triggered to the update capsule position and rotation, and then the action value to the add movement input. And then the only thing that needs to change in here is instead of get forward vector from the camera, since we're moving horizontally on this one, we're going to get right vector instead. So get right vector, and then press Q to realign that, and then connect that up to the world direction. And so here we go. We've got our code that allows us to move the joystick and then move our character in a certain direction based off the joystick. And then for this one, we're going to call this prime. We're going to drag over everything and press C to create a comment box. And this one will be primary inputs for Thumbstick Locomotion. Cool. So compile, save that, and then we're going to go up to the top, see where our event begin play is. We're going to drag over here, and we're going to drag out from the add input mapping context, and we're going to do update capsule position and rotation. We just want to do this as soon as we start the game, so it's on the frame that we want it to be on. There's a few other things I want to do while we're here that's going to help with this test. We're going to go from our primary inputs, we're going to go up to the input action snap turn. And when we're setting the input action snap turn, after we complete the snap turn, we want to update capsule position and rotation. So that way the capsule is updated to where we want it to be rotated with the snap turn. And then we can go ahead and test this out. And as you can see, we are moving hella fast, but we do have proper thumbstick locomotion in the direction we want to move. The first thing I think that we absolutely need to fix here is the speed of our character. So what we're going to do is we're going to go up to the top here where it says input mapping context off of the event begin play. And we're going to drag off of this. And we're going to do set max walk. What we're going to do is we're going to go to where this input mapping context is. It's at the very end of our event begin play nodes. We're going to go to our thumbstick locomotion and we're going to create a new variable. And this one, we're going to call this walk speed. We're going to set its category to our thumbstick locomotion category, and then we're going to compile it so we can get it its default value. Now, this value that you assign is going to be how fast your character walks. Like when they are walking, that's how fast they're going to be moving. I think my favorite kind of value for this when it comes to VR games is 150. It's like a general like walk forward speed, and it feels pretty good, and it's just what I prefer. So then we need to drag out a getter for that walk speed. And so essentially at the beginning of the game, as soon as we press play, it sets our walk speed to whatever our generic walk speed is. And in this case, I've set it to 150. So we'll go get a reference to our character movement component, which is in the components tab. We're going to drag off of that, and we're going to do set max walk speed. And this is actually a variable that is inside of the class settings for the character movement component. So if you were to grab the character movement component and you go to the details panel on the right here, you can actually see like max walk speed crouched, max, like a bunch of different values that control how the character moves throughout the space. It controls their physics. It controls how they interact with the unreal world. And you can do a lot of cool stuff in here, but we're only concerned with max walk speed. And we want to be able to set it with a editable variable. So what we're going to do is we're going to grab this max walk speed variable that we created. We're going to go to where it says instance editable, and we're going to click that so that way a little eye shows up on our left hand side. So now if we click on the pawn and we want to edit it directly, we don't have to go inside the blueprint to edit how fast their walk speed is. We can just do it on the fly in here. So we'll drag our max walk speed into we're going to drag our walk speed variable into our max walk speed setter, and that's going to set our max walk speed on event begin play to 150. Now we're going to connect these two up, and then the comment for this will be sets user specific speed. And the nice thing is we could loop this into a menu or option system of sorts, so players could actually set how fast they want to walk. So if someone was a little bit more comfortable going faster, they would have the ability to set their walk speed faster, within a given range. I don't want a player to be able to set themselves to 6,000. That would be stupid. Okay, so now we have pretty much the basic functionality that we need for thumbstick locomotion, and it's time to give it a test. So we're going to go to the VR template map. We're going to get our headset ready, and we're going to click play. Here we are moving around. I have my thumbstick locomotion working correctly. So if I want to strafe right, I can strafe right, and then it'll actually curve if I am, you know, looking in a certain direction, which is really cool. And then obviously I can go back and forward, but I still can't rotate. So we need to fix that. Okay, to fix our rotation issue, we need to go into our VR pawn, and then we're going to click on the VR pawn self up here. Then we go over to the details panel and we type yaw. What we're looking for is use controller rotation yaw. What this does when it's checked is it kind of locks the player camera to the capsule collision, and therefore we can't like rotate anything and the capsule's kind of blocking us. If we turn this off, compile, save, and then go test it. All right, so we now have walking forward, backwards, and strafing, and then we also have snap turn enabled. Before we go on to adding our sprint and jump functionality, we actually need to fix a problem we have with the collisions on our actor. Something you'll notice if you put on the headset and press play, and we were to take an object and drop in front of us, and then try and walk over that object, it causes the pawn to kind of glitch out. And the more objects those are, the more it kind of messes things up. And in some cases, we can actually like accidentally force ourselves, you know, back. These interactable objects are messing with our collision system, and it's causing an issue that we need to fix. So how do we fix something like that? A custom collision channel. So what we're going to do is we're going to go to our project settings. So we go up to the upper left corner, we press edit project settings. And then we're going to scroll down on the left hand side here and we'll go to collision, and we need to create a new object channel. So we're going to go new object channel, and this is going to be of type block, and we're going to call this interactable object. And we're going to accept and save that as is. After we create the interactable object channel, we need to go down to this presets tab here, and we need to create a new preset. What we're going to do is select new, and we're going to call this interactable object. The object type will be our interactable object, and our description will be allows user to interact with objects without ruining collision of character capsule. And then we will accept and save that. And then we need to go back into our VR pawn, and we need to find the collision settings down to the right here. Scroll down until you see collisions. We're going to set the capsule to be custom, and then pawn, and then down here where it says interactable object, we're going to set ignore. Right now it'd be set to block, so we're going to set it to ignore. We want it to ignore the interactable objects on the ground so that it doesn't trip over them and freak out physics-wise. We also need to change how this is picked up. We also need to change one of the functions inside of the VR pawn. So if we go to the functions on the left-hand side here, we have get grab component near motion controller. We need to zoom in to where it says make array. And we want to change this from physics body to interactable object. Otherwise, it's just going to automatically default it to physics body and then, you know, continue to mess up our collisions. Now we need to set the different interactable objects in our scene as actual interactable objects. We're gonna go into the grab cube first, and we're gonna grab the static mesh, and on the right hand side, we're gonna scroll down. We're gonna change this to interactable object. You know what I also forgot to do inside of this interactable object? We have to edit this, and we need to change it from no collision to collision enabled query and physics accept, and then file, save all, go back to our grabbable and recompile. Cool, that looks correct. Our VR pawn should be ignoring these, and then we'll also do the same thing for our pistol mesh. So we're gonna grab the pistol mesh, we're gonna go in here, scroll down to the collisions, we're gonna change that physics actor to a interactable object, and compile and save. And then finally, I want to go and change the projectile as well, so that it's not messing around with anything. And we're gonna go into our projectile, we're gonna grab the static mesh here, scroll down, and we want to, sphere collision, we want to change this for interactable object from block to overlap. And that way it can still shoot. And then finally, to finish that off, we're going to go into our grab component. We're going to go to the set collision profile of the parent right here. And we're going to change this from our physics actor to our interactable object. We have to make sure that this is spelled correctly because this is context sensitive. So let's look here, pistol interactable object. Okay, good, I spelled that right. So I'll go into the grab component, grab this, type interactable object, make sure that this is spelled correctly and there is nothing extra in here. Compile and save, file, save all, check the project settings, cool, and we will test. All right, so now if I get my controllers out and I walk up to this table and I grab the gun and insert it into myself, I am no longer pushing myself back into the ground. If I drop a cube on the ground and walk over it, I no longer kick it into space and completely jolt myself. Now we have our movement system, Thumbstick Locomotion, programmed correctly, and we can move on to our more complex interactions like sprint and jump. Now that we've finished our general movement for Thumbstick Locomotion, we can start adding our more complex interactions like sprint and jump. We're going to start with sprint. What we're going to do is go into the VR pawn, and we're going to create a new input action. So we're going to go IA_sprint. And we're going to actually end up using a lot of this node to trigger different things. The first thing we're going to do, though, is drag off of triggered, and we're going to create a branch node. And this is going to help us kind of determine whether or not we actually can sprint, and it's going to factor into our stamina system as well. So the first thing we want to do is drag off of this condition. We're going to type and boolean, and that creates an and condition. Basically, this cannot be satisfied unless two things are true. And the first one we're going to do is grab a character movement component. We're going to drag off of that, and we're going to do is falling, right? So we want to know if our character's in the air, because if our character is actively falling through the air, we don't want them to be able to sprint because there would be nothing for them to realistically sprint on. So we're going to drag off of this is falling, and we're going to type not. We're looking for a not boolean. So basically, if the character is not falling, we're able to sprint. The next thing we need to figure out is if the character has stamina. Now, when it comes to stamina and how this system works, we essentially need to make a few different variables, and we're going to make them as we go because it's going to be the easiest for me to explain them. The first variable that we need to create for this Thumbstick Locomotion stamina stuff is we're going to go to variables, we're going to click plus for variables, I'm going to type in, I'm going to select the new variable I've created and open it up. And in here, I'm going to type stamina. And I'm going to set this to Thumbstick Locomotion because it goes into Thumbstick Locomotion. And then we want to compile and save so we can get it its default value. Now, the stamina is always going to be a value of either 1 to 100, so I want our default value for stamina to start at its max. It's going to be 100. So essentially, we're going to drag in a getter for the stamina, which is set at 100. We're going to get a greater than or equal. So is the stamina greater than or equal to 0? And if it's, anything less than that, it's not going to allow us to sprint. If we don't have stamina, we can't sprint. And that's essentially what this function does. And then we're going to pull off of the true, and we need to set up our stamina depletion code. This is what actually causes our stamina to deplete as we're sprinting over time. The first thing we're going to do is drag off of our true node, and we're going to set stamina. And this essentially is going to allow us to set the stamina lower for every second that we're sprinting. Then we're going to drag off of the stamina, and we're going to create a minus or subtract float. And then we want to subtract from our stamina. So we grab our stamina node again, and we're going to get that. And we're going to basically be subtracting, a certain amount from our stamina every second. So what we need to do for that is we need to create a new variable, and this one will be another float, and we want to organize it into our Thumbstick Locomotion, and we're going to call this one stamina depletion rate. Compile so we can access its default value. And for the stamina depletion rate, I've found that 35 seems to be the best. So remember, it's not like we're subtracting 35 stamina floats every second. We're going to be subtracting this by delta time. So what we're going to do is we're going to pull off, we're going to do a multiply, and then we're going to drag in our stamina depletion rate and connect that to the A. And then we're going to go up to the very top here where it says event begin play. We're going to create an event tick. And then we're going to drag, actually, then we're going to create another variable, and this is float, and we're just going to call this one delta time. And the reason that we're doing this is because we're going to take this node, we're going to set it, and that way we can access this event tick wherever we need it inside this blueprint. Because I don't really like having big, long green lines being dragged through my entire blueprint. I want to be able to access, you know, pieces of it, essentially, whenever I want. So we're going to go back down to our stamina depletion code right here. We're going to grab our delta time float variable, and we're going to get that and drag it into the B of the multiply. And so now we have code that allows our stamina to be depleted over time. And we're just gonna kind of clean this up because we still have to insert a little bit more code in here to make it functional. So this is if stamina was successful, but what if stamina was unsuccessful or we run out of stamina? Since this is firing every frame, when we run out of stamina, it's gonna actually fire back through, except in this case, since the stamina is, you know, less than or equal to 0, it's gonna be false. So it's gonna have to go out. And so therefore we need to have some sort of logic that sets up stamina regeneration and also sets our speed back to normal. So first things first, we're actually going to set it so our speed increases once we start sprinting, and then we'll set how it decreases. So we're going to pull off here, and we're going to, actually no, we're going to pull out a reference to our character component. We're going to do set max walk speed. It's kind of the same thing we were doing at the beginning, except this time we're going to be setting it to a very fast thing. So on started, we bring out and we set our max walk speed. And then we're going to find our walk speed here. We're going to duplicate this variable. It's another float variable, and then this one will be called sprint speed. And I think the best way to do sprint versus walk is take whatever the walk speed is and multiply that by 2. So 150 times 2 is 300. I really hope that math is right. I don't know if that's right, whatever. So we're going to drag that out. I'm going to connect my sprint speed up to my max walk speed, and that's our sprint speed. And so essentially, you want to be able to edit these, and you can mess around with these values and make them whatever you want. I prefer, you know, a slower moving character if I'm making something like a narrative game, but maybe you want something faster. Maybe you're doing like some crazy roguelike with this code. I have no idea. It's a free country. Do whatever you want. And now we need to have, you know, the code reset. So when we run out of stamina, we're going to pull off of completed, because we're going to have this automatically end the moment that it's completed. We're going to copy this code here, the set max walk speed. We're going to paste it, and then we're going to replace that sprint speed with our walk speed. So when you stop sprinting, when you let go of the joystick, like the joystick button, you immediately stop sprinting. It's completed. And then we also need to have it so if we run out of stamina, it automatically stops sprinting. And for that, we need to create a Boolean. So we're going to go to our sprint speed. I'm going to just duplicate on top of this. And then we're going to change this to a Boolean. And we're going to call this Boolean is stamina cooldown. So if stamina is, like, if we're in stamina cooldown mode, as in like we maxed out our stamina and now we need to recharge it, we are going to trigger this Boolean called is stamina cooldown. And this allows us to do other things in the blueprint later on. Like, let's say we want to be able to climb or do something else. We can use kind of the same exact code for each thing, and we can use this main stamina cooldown system as its way to go. But let's say we're sprinting, we run out of stamina, we go through this branch, and then we immediately go through false. We can no longer sprint, so it's going to automatically set stamina as cooling down, and then it's going to set our max walk speed back down to our walking speed because we can't sprint anymore. And then at the very end here, since we also have to set it to stamina cooldown, so that way if we're sprinting and then we get halfway and then we immediately stop sprinting, we want to be able to recharge our stamina at halfway. Otherwise, we'd have to wait until it gets down to 0 to recharge every time. So that is the logic for the stamina depletion and use. We now need to add code in for how it regenerates, which will be the next step. So we're going to go directly beneath where we are right now. Oh, we're just gonna create a comment around this first though. So drag around all the nodes, press C, and type sprint. Sprint functionality with stamina depletion. And then right here, I'm gonna make a node comment so I know what it is, and I'm gonna say, it's just in case I come back to this years after writing it and forget what it is. So we're gonna go directly beneath this sprinting functionality, and we're gonna create our regeneration of stamina function. So what we do here is we create we're gonna create a custom event. So add custom event. We're gonna call this regen stamina. And pay attention to the spelling of this. We're gonna need it later. So for now, I'm just gonna copy it. And then I'm gonna go and zoom in on this so I can have a good idea of what I'm looking at. We're gonna drag out a branch node, and we need to check to see if our stamina is in cooldown, because if it's not in cooldown, we shouldn't be regenerating stamina, essentially. If the stamina is not supposed to be cooling down, we should not be regenerating past a certain amount. So what we're gonna do is, if stamina is cooldown, we can regenerate stamina. So we're gonna set stamina. And we're gonna line that up right here. We're going to then go down kind of underneath our Boolean, and we're going to create another getter for stamina. So we're gonna get our current stamina, and then we're going to create a new variable called, hold on, it's gonna be a float variable. It's gonna be in our Thumbstick Locomotion category, and this one is going to be stamina regen rate. So we have our stamina depletion rate and we have our stamina regeneration rate. They're different values because we want our stamina to regenerate slower. They're different values though. And you got to mess around with these values to get the feeling you like. I've found that stamina regenerates best if the stamina regeneration rate is set to 100. And then we're going to drag out another reference to our delta time, and then we kind of math these together. So we're going to multiply our stamina regeneration rate by delta seconds, Q to align, and then we're going to add that to our existing stamina. So multiply stamina regeneration rate times the delta time, then add that to our existing stamina, and then we set that. Oh wait, we can't just set it. We need stamina to be between 1 and 100, so we need to add a float variable. So we're gonna do clamp. Cool. We're gonna clamp this float value between 0 and 100. That way it's not setting our stamina to a random number, because floats need to be told exactly how high and low they can go. Otherwise they don't function correctly. It's kind of the ups and downs of working with floats. It's float math. And I went to art school. Okay, so finally we need to set some sort of logic to prevent the stamina from regenerating past 100%. You can only have 100% stamina at any given time. So what we do is we drag off of stamina and we go greater than or equal to. If stamina is greater than or equal to 100, we set up a branch condition. We link that up to our set stamina node, and then right past here, we're going to set stamina. Set is stamina cooldown, and this is going to be set to false. So if we reach 100, we stop cooling down stamina, we stop regenerating stamina, because, you know, we can't regenerate stamina past 100%. That's our max threshold of stamina that we're allowed to have. So we're gonna press C, and we're gonna comment this one, and this comment will be called stamina regeneration code. All right, so that's our stamina regeneration. We've got our sprint functionality. We now need to create a timer that actually sets our ability to continuously regenerate stamina, because right now there's really nothing telling the regenerate stamina event to play. So we need to go up to the very top past our sets user walk speed, and we want to create logic to start a timer that's constantly regenerating our stamina. So what we're going to do is we're going to drag off of our set max walk speed. We're going to do set timer by function name. And the reason I had us copy paste our regenerate stamina is because this function name needs to match our regenerate stamina event. Otherwise, this will not work. It's context sensitive. It's annoying that you can't just plug it in. You have to like copy it over, but it is what it is. Then we're going to set this to looping. So no matter what, it is always running. And then we're going to do it every 0.1 second. So every 0.1 second, we should be regenerating our stamina multiplied by the delta time. And then we want to set stamina to be cooldown false. So we want to drag off of that. We do set stamina. No, wait, sorry. Is cooldown. Yeah, there we go. We want to set stamina cooldown to false. We don't want it to continue regenerating past 100% because we're going to start playing with 100% stamina. And that is everything. So setup. We're gonna comment around this one, and we're gonna call it stamina setup. And this, essentially sets up our stamina. Now we can go and test this out. So this is my current speed when I am not sprinting, and then if I push the stick forward, I am now sprinting as fast as I can, and then I run out of stamina very quickly. So you can set your stamina higher or lower depending on what you want. Right now it's like super low, but it is what it is. And then we can keep sprinting until we run out of stamina, and then we stop, and then we can no longer sprint. And so play around with these values and find the amount that you like. This is up to you. And I've explained how it works so you can kind of understand the way that this system works, and then you can find the values that work best for you. This is super basic. I'm not even happy with what we just created. I'm gonna go back and edit it myself too. But now you know how to create a stamina system. Now that we've finished our sprint functionality, our final thing left to do is create the jump mechanic. Now we're going to be completely recreating the jump mechanic from the Half-Life Alyx, and it's essentially the teleportation mechanic as well. What it looks like is when you pull back on the joystick, a arc goes out and you see a pair of feet standing in front of you, facing in the direction that you would be facing when you finally teleport. But then one thing I noticed when I was playing recently that I've actually never noticed before is that if you wait long enough, a pair of footsteps actually walk from where you, the player, are standing to your projected teleport location. And I really wanted to include that because I thought it was super cool and a really good opportunity for us to do some VFX and a little bit of AI. So we're going to jump into this, and we have to do it in kind of multiple parts. So we're going to start out with the functionality first, and then we're going to make it look pretty afterwards. So we're going to start out by creating those actual blueprints that we use to spawn the feet. I want you to go out to the VR template and then go into blueprints. The first one we're going to create is called a actor class. So we're going to go blueprint class of type actor. And I want you to call this one BP underscore Alyx jump. And we're going to enter this one. And then we're going to go back out. And we're going to create another blueprint. And this one will be a character. And we'll call this one BP underscore footsteps AI, and we're gonna save the two of those in case I can't remember if I forgot to snap or not. Okay, and then what we want to do is add a mesh that we can use as the footsteps, and the best one to use would actually just be the you know, standard Unreal mannequin. So what we're going to do is we're going to go to the content browser in the upper left hand corner. We're going to go add, and then we're going to do add feature or content pack. And we want to select the third person, and we're just going to add that to project. And what that's going to do, it's going to add all of the code that goes into that code template so we can use it for our purposes. So as you can see, we finished that out, and we brought this in, and we now have that third person blueprint. We've got its animations and everything we need to make this work. So we're going to go back to our VR template. We're going to go to blueprints, and we're going to go into our BP_Alyx jump blueprint. And in here, we need to create a skeletal mesh. So we're going to go to the add component on the left-hand side here. We're going to go add, and we're going to do skeletal mesh. And we're going to call this feet mesh. So F-E-E-T. And then what we want to do is go over to the right-hand side where it says skeletal mesh asset. And we want to get SK Quinn. We want to get SKM Quinn simple. We drag that in and it looks like this. Now, this is going to be rotated wrong, and so we need to actually apply some rotation to it ourselves. Otherwise, when we actually do the teleport effect, the feet are going to be turned in a weird direction and it's not going to make sense. This took me a long time to actually debug, and it was a lot of trial and error. But what we're going to do is we're going to go to the rotation on the right-hand side in the transforms here. And we're going to go to the rotation on the Z, and we're going to change that from 0 to 270. So it's going to rotate her like that. And then we want to flip her on the Y-axis. So make sure that this little lock is switched off because we only want to flip this on the Y-axis. And we're going to go to the Y, and we're going to change this from 1 to -1. And that's going to flip her around. Okay, so that's finished. And then we're going to go into the event graph. And we need to add some specific logic to tell this thing where it's supposed to be when we're teleporting it in. What this is going to be like a little placeholder. It's going to show us where we're going to be teleporting, and we'll make a holographic material for it later, but right now we're just going to deal with the basic mannequin. But we need to add some logic so it follows our projected teleport location. So what we're going to do is we're going to go into the event graph, and we're going to find the event tick node, which is in the lower left right here. We're going to drag off, and we're going to cast to VR pawn. And inside of this, we can't really direct reference, except the nice thing about casting to this VR pawn is we don't have to do any like weird get actor stuff. We can actually just drag right off the cast to VR pawn and do get player pawn. And since this is, you know, single player, this is the index player pawn, and no matter what, this cast will not fail. Which means we can pull a bunch of variables out of the VR pawn to make this teleportation or jump functionality work. So let's start by pulling out of the as VR pawn, and we're going to get something called the projected teleport location. Now, this is code that was written by Epic that actually does the teleport that we were looking at earlier. What we want to do is, you know, take that variable, and that's what we're going to tell the feet to spawn at. It's going to constantly set itself to that world location based off of where we're aiming, you know, the teleport. So we'll do that first. And then we're going to pull off of as VR pawn again. And this one will be camera. We want to get the camera. So it's not going to come up right away. You're going to have to scroll all the way down to the bottom. And we're looking for get camera, right? And then from there, we want to get the forward vector. So we're going to get forward vector. And we want to pull off of the get forward vector and do a find look at rotation. And we need to set, this is like this, we're basically getting the camera rotation, and we're going to set this actor's rotation to the camera rotation of our pawn. And we need to do it not like a direct set, otherwise it'll just kind of exponentially rotate to the point where it's just constantly spinning. We needed to look at where our rotation is, and then look at where its own rotation is, and then set its rotation to match that relative rotation. It's the only time I've ever actually really had to use a relative rotation, so it's kind of cool that we get to do it for this tutorial. So we're going to go get right vector, and then, we're going to grab the feet mesh, which is what we created inside this blueprint. It's the skeletal mesh, and we're going to drag off of that, and we're going to do get right vector. Go ahead and press Q to align these two, and that's going to go into the target of our find look at rotation. And then after that, we want to drag off of the cast to VRPon, and we're going to do set actor location. So we're setting our own location to the projected teleport location. And then we want to set the relative rotation. So what we're going to do is we're going to drag off of that. We're going to go set relative rotation. So right here, we're getting the relative rotation of the feet mesh, and we're setting it to match the rotation of our camera. Oh, and another thing to stop it from spinning, we're not actually setting our feet mesh rotation. We're going to drag off, and we want it to be the default scene route. All right, so we just want to split this struct pin, and then we want to split the struct pin of our set relative rotation because we're only concerned with its rotation on the Z axis. So we'll drag out from the Z on our find lookout rotation and put it into our set relative rotation of our feet mesh. So now the feet mesh will match the rotation of the camera on the Z axis. And that is all the code we need to do inside of this blueprint until we add the materials later. So we're gonna comment over the top of this, and we're going to drag out this event tick in case we ever need to add anything else in the future. And we're going to label this sets the location of the feet mesh to the same, this one will be sets the location of the feet mesh to the same rotation that the user is facing. And then we're going to save that, and we're going to close this. We now need to actually add some references inside of our VRPon. So we're going to go back to the VRPon, and we're going to go up to our teleport. So input action, move teleport. And if you remember at the beginning of this tutorial, we actually deleted the IA move from our IMC defaults. So we need to replace this with our updated input action. So we're going to go IA, then we're going to go jump. We're going to grab our jump input action. I don't know why there were two. I'm confused as to why there were two. Which one is which? Are there two existing in the... Jump, 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 jump. No, it looks like not. Well, what we're going to do is drag in this IA jump action, and we're going to reconnect it up with our existing teleport functionality. So we'll drag out from triggered and set that to teleport trace. We'll drag out from started and set that to start teleport trace. And then we'll drag out from completed and drag that to end teleport trace. Now we can delete this original input action event because it's not necessary anymore. We're gonna drag that in. We're gonna change this comment to input action jump. And then we're going to... So in our input action IA jump at the very end after the try teleport, what we wanna do is drag out and do update, capsule, and drag out and do update, capsule position and rotation. That way, as soon as we teleport, it updates where our capsule is, so that way we don't teleport and leave it behind, especially when they get complex like this. Now we're gonna actually open up our start teleport trace function, and we need to go over to where it says teleport visualizer reference, and we need to spawn in that jump actor that we made. So what we're going to do is drag off of the teleport visualizer reference. We're going to do spawn actor from class. And then we're going to grab the, we're going to type in Alyx jump. So we're going to be spawning that in the world when we start, when we start our teleport trace, essentially. We're going to split this struct pin and make sure that everything is 0, 0, except for the spawn. We want to leave that at 1. And then the owner of this is going to be us. So we're going to do owner, and we're going to type self. So we're going to get a reference to self. That way, the owner of this actor that we spawn is the VRPon, and therefore we can do things like destroy it when we no longer need it. And then finally, we're going to go to this return value of the BP Alyx jump. We're going to right click, and we're going to do promote to variable. And we're going to name this variable jump ref. And this should be organized into that thumbstick locomotion category because it is part of that. Oh, and when we create the jump ref variable, please make sure that you do not create a local variable. We need to create a global variable. So we'll go back to our BP Alyx jump, where I created that reference before. We're going to right click on that. We're going to do promote to variable, and that gives us BP Alyx jump. And then in here, we're going to write out Alyx jump ref, and we'll set that to thumbstick locomotion. And then we connect that right up. So it's after we spawn it, we set it. So basically what happens is when we pull back on the stick, it should spawn in this BP Alyx jump actor to where it needs to go and also set its location to the end of our thing. Also, before we test this out, just go ahead and remove the self from the owner. We do not want to own this. I made a mistake. In the pawn, we've set the spawn actor Alyx jump to the jump ref. It does not have an owner. And then in Alyx jump, we're setting the default scene route to match our character's rotation. We can actually go and test this out and make sure that it's spawning and rotating correctly. So we'll press play. We'll go into our scene. So now that we're in scene, we've set those things up correctly. What we're going to do is we're going to rotate. And if we move this around, as you can see, depending on where my head is rotated, this character is following that rotation as well. So if I put it straight forward and I look right, my feet turn right. And if I look left, my feet turn left, which is awesome. And no matter how I am rotated, that will always be faced away from me and rotating correctly. And then I can just teleport to its location. Now the problem is whenever we do that, it doesn't disappear. So we need to add in some code that causes it to destroy itself once we no longer need it. So what we're going to do is we're going to go into the VR pawn. We're going to go to the event graph. And we're going to go to the end teleport trace. And right here, we need to look for the end of this. We need to go to the end of this function, essentially. We're going to find our jump ref. We're going to create a get. Then we're going to right click on this and we're going to convert to a validated get. And we're going to put that at the end of our teleport trace function. And essentially what we're looking for is after the teleport is finished, if the Alyx jump ref is still valid, we want to destroy it. So we're going to do destroy actor and make sure you connect up the Alyx jump ref to the destroy actor. Otherwise, it'll destroy the pawn. All right, now we can go back and test it again. I'm standing here. I pull back for teleport and I let go and it destroys itself. Then it spawns another one and it destroys itself again. And then it destroys itself again. So essentially, no matter what, we will just be creating this spawner, and then as soon as we don't need it anymore, after we teleport, it's gone. Now we need to create the logic that causes the footsteps to walk from our character pawn in space to the teleport location. So what we're going to do is we're going to go into our BP Footsteps AI, that character blueprint class that we created earlier, which is inside of the VR template blueprints. We're going to open that up. And we're going to go to the mesh, that character mesh that we were talking about before. And I'm going to type in skm underscore, and we're looking for Quinn simple. And then we're going to take the animation class here, and we're going to do ABP Quinn, because we want to use her animations for like the walking portion. And then what we're going to do, set her to correctly match the direction she's supposed to be facing. So we're going to go on the Z again, and we're going to set her rotation on the Z to 270. And then we're also going to drop her down so that she's on the floor. So we're going to do -90, and that'll put her directly at floor height. So she'll be walking around along the floor as she walks to her teleport destination. And then we want to actually change her speed so she's a lot slower, because we don't want her sprinting to the end. So we're going to go and we're going to change her max walk speed to be the exact same walk speed as our player would if they were walking instead of jumping. So set that max walk. So basically, to set the max walk speed, we're going to go down to the details panel. After we select the character movement component, we're going to select the max walk speed, and we're going to change that from 600 to 150, and then we're going to compile, and we're going to save. Cool, now we can actually add the logic that tells her that she needs to walk somewhere when she spawns. So we're going to go into the event graph, we're going to get rid of everything but the event tick. And then the first thing that we're going to do off the event tick is we're going to drag and we're going to cast to VR pawn. And then we're going to drag off of that. We're going to do get player pawn, so that way the reference will never fail. And then we want to pull off of as VR pawn, and we're going to call that projected teleport location node that we called earlier. And then we also drag off of as VR pawn, and we do the Alyx jump ref that we created earlier. And then we want to pull off of this cast to VR pawn, and we want to do an AI move to. And that looks like this. Now, something I want you guys to know about the AI move to before we move forward. The AI move to is entirely dependent on the character movement component and also the nav mesh that you have running in your scene. Now, in order to teleport as a VR person, you need to have a nav mesh in the scene in order to do that. With Thumbstick Locomotion, that eliminates the need for this nav mesh. However, if you want to do this jump mechanic where we're using, the teleport functionality to do it, you do need to drag in a nav mesh to the scene and set it up correctly. It's very simple to do. Imagine that there was no nav mesh bounds volume in here. I would literally just go and I would grab a nav mesh bounds volume, and then I would just drag it into the map pretty much anywhere I want. And what it does, if I, set it on something correctly, like here, for example, it looks like this collision is saying, a character can move here or not, and I want to change that. Basically, it would fill it in the way we want it to go. So that's how a nav mesh bound volumes works, and this functionality is dependent on there being a nav mesh bounds volume in the scene. I just wanted you guys to be aware of that in case you try to put it into a new level and it stops working. Back to the functionality. What we're going to do is we're going to drag off of the pawn and we're going to type self, because we need it to know that it's moving itself and not like our character pawn, right? And then we're gonna set its move to destination to be that projected teleport location. We're gonna set its acceptance radius to 2, so it's gotta be kind of right on top of it. And then we want to set the target actor to be that Alyx jump ref from our VR pawn. Essentially, it's got to go to the projected teleport location and then also overlap with the jump ref mesh that we've created. And then we want to give it something to do once it actually successfully does that. So on success, what we're going to have it do, actually, we need to add some more functionality into our VR pawn. So we're going to go back to the VR pawn. We're going to go to the event graph, and we're going to go over to our input action move jump. And we need to create a new event here. So what we're going to do is we're going to drag this out, this teleport trace. We're going to break the connection real quick. We're going to drag off of triggered, and we're going to make a sequence node. And we're going to connect the then 0 back into the teleport trace because we don't want to break that. And then we're going to drag off of then 1 and go down here, and we're going to type a do once. Now this do once is really handy for making logic fire until we ask it to reset again. So it will fire, and then it'll wait to fire again until we tell it to. And we need to define that logic, and we're going to do that with this event. So what we're going to do is right click, we're going to do add custom event, and we're going to call this custom event unset footstep ref. And then that's going to plug into the reset, but we need to put some other functionality in before we can do that. So we're going to scroll down underneath our stamina regeneration code, and we're going to do some footsteps code in here. So what we're going to do is we're going to go right below our stamina regeneration, and we're going to add a new custom event, and we're going to call this spawn footstep AI. And we're going to drag off of this. We're going to do a delay, because I don't want this to fire until we've been holding down teleport for about 3 seconds, because that's kind of what it looks like in our reference video. And then we're going to drag off of that, and we're going to do an update capsule position. And then from there, we want to drag off, and we're going to do a spawn actor from class. And I think you can tell where this is going, but it's going to be that footsteps AI that we were just working in. So we're going to do BP footsteps AI, and we spawn in that character. We're going to break this struct pin so we can actually see what we're dealing with. And then we're going to actually split the location struct pin into, split struct pin. And then we want to split that struct pin so that we have access to each of the location values. And then just to kind of finish this out, we want to pull off this return value, and we do a spawn default controller. And this actually engages our AI. So when we spawn it in the world, when we activate this, it's not going to move unless we tell it to also spawn a default controller. Because we're spawning it from the pawn, it's not existent in the level yet, so we need to tell it that it needs to spawn with, the ability to control itself as well, and that's what that node is for. And then we also drag off of this, and we do we right-click on this return value again, and we're going to do promote to variable, and we'll drag that out, and this will be footsteps AI ref, and then we plug that in like so. And then just double click to make some reroute nodes so we can kind of tell what we're looking at here. And right now, the way that this spawner is actually working is we're spawning it at 0, 0. We need to change that so it's spawning in a better spot, where our feet are in the world. But we also need to set it up so that this does not fire if there's already footsteps in the scene. So what we're going to do is we're going to grab that footsteps ref that we created, and we're also going to set its category on the right hand side here to Thumbstick Locomotion, so it's in the right spot. We're going to drag this out and grab a get footsteps ref. We're going to right click on that, and we're going to get a validated get. We're going to plug that into the delay, and then this only runs if the footsteps ref is not valid. So if it's valid, we want it to do nothing, and if it's not valid, we want it to go ahead and spawn some footsteps ref for us, right? We want it to spawn the footsteps if there are no footsteps that exist, and if there are footsteps that exist, we don't want it to do anything. And this is going to kind of fire every 3 seconds, So if it's super far away, it's going to take longer than 3 seconds to walk out there. We want to give it the time to complete that animation. And when we're spawning these footsteps and dragging out, right after the validated get, what we want to do is from the is not valid, we want to do update capsule position and rotation. And that way we are properly calling this event. All right, now we need to make it spawn at the right location. So what we're going to do is we're going to grab a reference to our capsule component, our player essentially, and we're going to drag off and we're going to do get world location. And we want to align this with Q and then split the struct pin. And we want to connect the X straight up to the spawn transform location X, and then the Y to the Y, and then we got to do a little bit of math here for the Z. So what we're going to do is we're going to drag off the Z, we're going to get a subtract float, and then we're going to drag off of, actually nope, we're going to pull out a reference to our capsule component. We're going to get, we're not going to do that. We're going to get capsule half height, and then we're going to drag that in so that way it's spawning at the right height. We want it to spawn exactly at our height and not taller than us. And then we're going to drag that subtract directly into the location Z. And then we leave the rotation at 0 because it's automatically going to rotate to where it needs to go, and we don't need to tell it to go anywhere special. And we're going to call this entire function spawn footstep visualizer when user tries to teleport. Cool. Okay, and then we're going to go back up to our input action move jump, and we're going to pull out the, we're going to pull out a reference to our footstep AI. We're going to set it, and we are going to connect it to nothing. So what we're doing here, the reason I'm dragging this in and I'm setting this is because I want to unset this footsteps ref, right? So I'm setting it to nothing when I don't connect anything up to it. And then that goes into the reset of our do once node. And then just to finish this off, we want to spawn the footsteps effect. So basically we're unsetting this after it reaches its location, but the first time it runs through, what it's going to do is it's going to spawn footstep AI. So we're calling that function that we just created earlier, and then it's going to run until it gets deleted, and then it will run back through and respawn it. So this will just keep going and going and going until we teleport. And if not, it'll just, keep going forever. Now we can go back to our footsteps AI and finish up the logic in here. So the first thing we want to do is off this top execution bin, we're going to drag out and we're going to do an is valid. We need to make sure that this exists before we do anything crazy with it. So we're going to get the Alyx jump ref and we're going to plug that into the input object. So if it's not valid, stop doing anything. Just straight up go into the unset. Oh, wait, sorry. We're going to pull off of our asVRPon again. We're going to call that unset footsteps ref so we can unset our footsteps ref and then also restart that do once node. And we're going to connect the is not valid up to that unset footsteps ref. And then if there is no footsteps, there is no jump actor, we want to destroy this AI component because we don't want it to be in the scene if it's got nowhere to walk, right? So we destroy it, and that's the last thing it does. And we don't put any logic after destroy actor because once the actor destroys itself, it can't run any more logic. And then if the actor succeeds, like let's say we have a teleport location, the AI reaches that teleport location, and it gets there and it pings a success on the AI move to node, we want it to unset that footsteps ref and then destroy itself as well. That should be pretty much it for the logic of this command. I just want to kind of clean up this function here, drag it forward a little bit, and then we're going to give this a comment of spawns footsteps until user teleports. Cool. And let's test this out and see if it works. Oh, actually, there is one more thing we need to do inside of the BP Footsteps AI. In the past, when we'd be setting up an AI blueprint and have it move around, we wouldn't ever need to do this, but the Unreal 5 mannequin and animation blueprint works a lot differently. We need to go into the character movement component, and we need to type use acceleration for paths. So if we didn't do this, the feet would kind of just slide into place instead of, walk the way that we want them to. And this will allow them to actually walk in the direction we want them to, and then stop where they're supposed to. And the animation should line up, as well as if there's any change in elevation, it'll follow that with the foot IK that's included in the animation blueprint. So let's test this out. Okay, so we're going to pull back on the stick, and in 3 seconds, a mesh should spawn and walk over to where we need it to go. Now if I move it, it should follow until it gets to where it needs to go, and then it'll delete itself. Perfect. Okay, so that's it for all of the logic we need to do, and all that's left is just creating a holographic material to give us that kind of footstep effect that we see inside of Half-Life Alyx. So we're going to go over to our VR template, we're going to go to materials, and we're going to create a new material. So we're going to right click and create new material. We're going to do M underscore holograph footsteps, and then we're going to create some material instances of this. We're going to do 1, and this will be MI holographic footsteps 001, and then we're just going to go ahead and duplicate that, and this one will be MI holographic footsteps 002. And then finally, we want to do a third duplication of that, and this one will be holographic footsteps 003. All right, this will all make sense in a second. The reason we need to make 3 of these is because we're doing different blend lengths for how we're going to actually mask out this mesh. and it'll all make sense in a second. For now, what we're gonna do is we're gonna do File, and we're gonna save everything. We're gonna close out our other blueprints. We're gonna go to our third person. We're gonna go to Characters, Mannequins, Meshes, and we're gonna drag out our Quinn simple so we can actually see this material in action on our character. Now let's go back to our materials. Let's go back to our materials here, which are located in VR template materials. We're gonna open up the m_holographic footsteps. That's our master material. And then we can create our holographic footsteps material. Now, this material is slightly complex. Please stick with it. I'm going to do my best to explain how it works and what we're doing. But, you know, when it comes to actually creating materials, I'm pretty new at it. And so when it comes to explaining how they work, it's rough. I mean, I've been doing this for a long time, but it's never something I've done a tutorial on, if that makes sense. Okay, so the first thing we're going to do is grab our holographic footsteps material. We're just going to click on this main node here, and we're going to change it from opaque to translucent, and we're going to change its shading model to default lit. And then we're going to drag this over to give ourselves a little bit more room, and we're going to start out with the emissive color. So we're going to go over here, and we're going to do a texture sample. And we're going to create a texture sample parameter 2D, and we're going to do object base texture. And then we're going to drag this out, and we're going to do a static switch parameter. And then this one will be use base texture. This is important if you want it to have, you know, the original texture of the mesh underneath it, or if you just want to use, you know, the standard mesh stuff. Anyway, we're going to go into this object base texture, and we're going to look for Quinn. Yeah, like one of her base color meshes. So Quinn 02 ID diffuse. And then we're going to drag out of the false of this static switch parameter. Actually, nope, we're gonna press V to create a vector parameter. And this first one is gonna be hologram color 2. And I wanna make this kind of like an orange. So we'll drag that up like so, and if you want to save that color, you can just drop it right there like that. And then we're going to copy this and paste it down below, and this will be hologram color 1. I know we did it in kind of reverse, but that's just what my notes are looking like. And we're going to change this one to be more of like an actual yellow, and we'll shift A to align these, and we need to kind of figure out how these are going together. So we'll drag this up like so. And then I want to drag the hologram color 2 into the false of the base texture. So if we're not using a base texture, I just want to use like another gradient hologram. So that way we have like some interesting colors going on. And then if we are actually using the base texture, we're going to do a multiply. We're going to connect the A up to our hologram color 1. And then we're going to drag off of that, and we're going to create a scalar parameter, and this one is going to be called emissive intensity, and I want our emissive intensity to start at something smaller, like 40. It's got a decent glow to it. And then we're going to drag off of the use base texture. We're going to do another multiply, and the B of the multiply will be our bottom hologram color 1 with its emissive intensity. And then finally, we're going to drag off of, actually no, we're gonna press M on our keyboard and we're gonna click to create another multiply. We're gonna drag this multiply up top into the B of our other multiply. And then we're going to create a Fresnel. And for this Fresnel, we're just gonna leave the base settings as is. And then we're going to, yeah, no, that's fine. And then we'll connect this up to our emissive color. So that like basically decides, you know, the overall color and glow of everything. So now you can see it's got this kind of like interesting glow material to it. And that's exactly what we're looking for. Now we need to set, you know, the opacity and also like our fading. So that way we can cut off like the top half of the mannequin's body. So it's just the footsteps and the feet. So we're going to start with the, we're going to start down here and we're going to do a texture coordinate. And from the texture coordinate, we're going to drag out and we're going to create a panner. And we're doing the scan lines right now. So we're going to create a panner and then we're going to create a scalar parameter by holding S and clicking somewhere in the graph. And this is going to be scan lines speed. And I want to set this to 0.2 or somewhere around there. And I want to connect that up to the scan lines speed. So like the speed of our first panner. We'll align that with Q. And then we're going to drag off of the texture coordinate. We're going to create another panner. And then that's also going to use the same speed node that we had before. And then we need to create 2 new texture samples. And this will be our scan lines and then a Perlin noise map to cause some like kind of distortion because that's what we're looking for. So we're going to drag off of this first panner. We're going to do texture sample. And then we're going to create another texture sample. And so for these textures, you can go and find your own, or you can follow my Gumroad link that's in the description, and you can download the 2 textures that I created in Photoshop for this, but I'll show you how to load those in. So basically, once you have downloaded the... Okay, so I have uploaded these 2 Targa materials to my Gumroad for completely free. So you can just go to my Gumroad page and download them for free, and then you can actually drag them into the project and use them for this material. But for now, I'll show you how to import those real quick. So what we're going to do is we're going to go into our content. We're going to create a new folder by right-clicking and pressing new folder. We're going to call this textures, and then we're going to click into these textures. So what we're going to do is grab our T_QK scan lines and T_QK Perlin noise. We're going to select both of those and we're just going to drag those into our new textures folder so that we can use them in our material. So those are imported. We're going to file, save all. We're going to go to our holographic footsteps, and this top texture is going to be our scan lines. And then our bottom is going to be the Perlin noise, which is going to distort the scan lines so we get that cool, like kind of distorted effect that we see in Half-Life Alyx. So that's those 2 set up in here. And now we need to kind of multiply these together and then multiply them by a vertex normal to give them that kind of weird wavy distortion. Because right now they're just going to kind of appear flat. So what we're going to do is drag off of our top texture sample first. We're going to do a multiply. So multiply M. And then we're going to do the same down here. We're going to press M for multiply and put that node there. And then we're going to create a scalar parameter for the bottom here. And this one is going to be scan lines intensity. We're going to create a scalar parameter by holding S and clicking on the keyboard, and clicking on the graph. We're going to call this one scan lines intensity. And then we're going to set that default value to 0.2. And then we're going to copy and paste this below. And this one we're going to call distortion. And then that one will also leave at 0.2. And so the scan lines intensity, that connects to the B of the scan lines multiply, and the distortion strength connects to the multiply of the texture sample. Also, don't spell distortion strength or strength wrong like I did here. That was dumb and I don't feel like fixing it. Okay, so now we need to add a add node. So we're going to drag off of this bottom multiply and we're going to type add, and that creates an add node. And we're going to add that directly on top of the multiply from our scan lines texture. And then we're going to drag our color section up a little bit higher to give ourselves a little bit more room. Oh, and also we're going to comment that this is, you know, shader color. And then we can scroll down here, and we'll do, from the add, we'll pull and do another multiply. And this is where we're gonna add that vertex normal to give us that cool distortion that we want. So we'll drag off of the B, and we're gonna type vertex normal. Sorry, vertex normal world space, that one. Okay, and we'll drag that in. And then for, we'll create a scalar parameter, and we'll call this extrusion. Extrusion height, and I'm gonna set this at 5 for now, and you can actually change this. This is how distorted those lines are gonna look in the actual material itself. So for now, we'll leave it at 5, and you can change it later if you want it to be more or less. Then we're gonna create another multiply because we need to multiply this along with that vertex normal that we had before. And that it looks like this. And then this entire function that we just created is gonna connect into our world position offset to give us that cool, you know, vertex thing. And now all we need to do to finish this out is, oh, and as you can see, we don't have the opacity that we want yet, but we do have that cool like wobbly effect going on. It looks like a, like, you know, like a burning orb now. And honestly, we could probably use this to create a burning orb later on if we wanted to. But let's program the opacity and get this cool holographic effect. So this is probably the most like complex and annoying part of this material. But for now, I just want to comment this out, and we're going to call this scan lines and distortion. And then we're going to go down here. And yeah, no, this definitely took me the longest time to actually figure out. And so I'm glad that we got it done for this tutorial. So we're going to do a scene texture custom depth. So we load in a scene texture, and we change this to custom depth. And we're going to drag out of color and do a component mask. And then we only want the R channel masked out for this. Q. And then we're going to drag out a subtract. And I think the best thing to do would be pixel. Yeah. So then we'll do a pixel depth and connect that up to the subtract. Q. And then from here, we drag out from the subtract and we do an add. And we want to use this to kind of mess with the offset, like the depth offset. So we're going to create another scalar parameter. And this will be called depth offset. And I want to set this at like 0.9 for now. I think 0.9 is a good like starter value that'll just look okay. And then from there, we're going to create another multiply node, and the add goes into the B of that multiply. And then we just create another scalar parameter for like the base opacity. So we're gonna go opacity, and this is gonna control like how opaque the entire material is. And like whenever I'm making something that's slightly transparent, I always start with 0.4. It's just like a really good like, you know, mid value, I think, for something that should be, you know, slightly translucent. Okay, now we get to connect up the end of this into our existing code. So we're gonna go up to the multiply from our scan lines, and we're gonna drag out and we're gonna do a lerp, and that would be linear interpolate. There you are. Okay, and so that goes into the A, and then we're going to connect up our base opacity, and then we're gonna connect up this function that we just created to the B. And so we're kind of lerping these two on top of each other. And for the alpha, so that way we can actually get like a translucent spacing of scan lines, we're gonna go up to our scan lines texture that we created, and I added an alpha channel in here, and we're gonna connect that up to this alpha. And so that actually is gonna give us the cool like scan lines distortion that we want. And if I preview this, you can actually see what that looks like before we see it in the final material. So let that like compile real quick. Okay, so yeah, we want to connect that alpha directly up to this lerp, and then we need to create some other parts of our opacity code before we can finally connect this up to the opacity node on our master. So we're gonna go down below this, but before we do that, we'll actually comment this, and this will be base opacity and plus inner face culling. And then we're going to create like the actual opacity fade that helps us like cut the character in half, or, you know, just cut them down to their feet. And this is some like more, you know, kind of cool shader math that we figured out. So what we'll start with down here is a absolute. We'll do a world position, and that gives us the absolute world position. And then beneath that, we're going to do an object position. Yep, object position world space. We're going to drag off of the Z, and we're going to do a component mask. And we want to mask out everything but we just want to mask out the blue channel from this. And then we're going to create a subtract node. And we want to subtract the object position, but we want to subtract just the blue channel of it. So we're going to do another component mask, and this one will also just be blue, and we're going to plug that into the B of the subtract. And then we go down and we do another lerp, so linear interpolate. And then for the B, this is actually where we're going to set up like how we mask shit out. This is where we're going to set up how we actually mask stuff out. So we're going to create another scalar parameter by holding S and clicking on the graph. We're going to call this mask height. And I think that a really good, decent mask height is 55. Yep, 55. And we're going to plug that into the B. And then we're going to leave the alpha at 0.5. And then we need to actually flip this, because if we don't, it's going to cut off the top half of the character when we need to cut off the bottom half. So we're going to do a 1 minus x. So it's just a 1 minus node. And then this actually splits into two different sections. So from this lerp, we also pull off, and we're going to do a divide as well. And then we're going to create another scalar parameter. And this one is going to be called fall off. And for the fall off, we're going to set that to something reasonable, like -40. Yeah, -40 is good. Then we'll drag that off, and we're going to do a multiply. And we'll plug in the fall off to the A, and the mask height from our before function is going to go to the B. And then we are going to pull off of our 1 minus up here, and we're going to do a seal over a smooth seal. Yeah. And we'll clamp that too. So we'll do a clamp, and it'll be a minimum of 0 and a maximum of 1. And that helps us like more smoothly fade this. And then from the divide node, we're going to do an absolute to give us an absolute value from, the random number that's going to come out of these, functions. And then we're going to multiply that by, I don't know what to call this variable. I'm just going to call it multiplier. we're gonna multiply it by a multiplier. Yeah, multiplier. And we'll do, I'm just going to do like 60. This could honestly just be a constant, but in case we want to change it in the material instance, it's good to have it there. So we'll drag that up, and then we can actually connect these two together now. So we're going to do a multiply node, and then we're going to we're going to do a multiply node, and we're going to connect the bottom multiply to the B of the top multiply. And then we're going to go up to our base opacity interface culling. And since we're kind of finished with this math here, we're going to call this our opacity fade control, since this controls how the character is fading out, like when we're fading out different body parts and stuff. And now we need to multiply this with our other opacity multipliers and finish out this material. So the first thing that I want to do is from this bottom multiply, I want to drag up and make another multiply. Actually, no, wait. I want to drag off this lerp, and I want to do a multiply. And then I want to drag off the B and connect it to our bottom multiply of this bottom function. So now we have this. We can close that lerp. And then this connects directly. And then this multiply connects directly into our opacity. And now we can apply and save the material. And so you can see we've got this like cool distortion effect, and it's fading correctly. And let's see how that actually looks on our mannequin. So we're gonna go to our content. We're gonna go to our VR template materials, and we're gonna go to, we have footsteps 0, 1 and footsteps 0, 2. And it looks like we need to go in here and change some things real quick. The annoying thing about the Quinn mannequin is that she's got 2 material slots, and it's annoying because if we want to have a cool holographic effect, we kind of have to like put these 2 on top of each other, and it's just like extra shaders for literally no reason. We could put her into Maya and fix this, but for the speed of this tutorial, we're just gonna kind of deal with it. So we're gonna take the footsteps, holographic footsteps 0, 0, 1, and we're gonna put that on top of 0, 0, 1, and then we're gonna put that next one. We're gonna grab holographic footsteps 0, 0, 2, and we're gonna put that right here. And then we're actually going to go into this material, and we're going to go back out to Quinn, and we're gonna click this little browse to select her. And then inside of the material instance, if we click this little cinder block on the bottom right, we can actually take a look at her feet and how they're blending. So we're gonna go to our holographic footsteps, and we're going to activate a few of these. For our distortion strength, we're gonna change this from 0.2 to 0.02. And that's gonna give us a little bit better value. And then we're gonna go to our extrusion height, and we're gonna change this to a 3. And then we're gonna go to our mask height, and we're gonna change this from a 55 to a 45. And then we want to go to our hologram 1 and 2. And man, it's just so dim. Let's change up our emissive intensity too. There we go. So we'll change our emissive intensity as well, so that it's a little bit, yeah, that looks so much better. So we'll change that to be more correct. And yeah, that looks pretty good. So we will set that as so, and yeah, no, that looks great. So now that we have set our MI holographic footsteps to be correct, we'll go into here, and we're gonna close our master material. We're gonna delete this mesh out of here, and then we're gonna go and find our VR template. We're gonna go to blueprints. We're gonna find the Alyx jump blueprint. We're gonna go to the viewport and find our feet mesh. And then in our element 0 of the feet mesh material, we're gonna change this to our MI underscore QK, or sorry. mi underscore hologram footsteps 01. And then this next one will be footsteps 02. And so we'll have that finished. Now we need to do the same thing for our footsteps. So we're going to open up our footsteps AI. We're going to go to viewport, go to our mesh, and we're going to do the same thing. So we'll find the material slots, and we'll go mi holograph footstep 003, 02. So we got our top invisible, and we're going to go into our footsteps 003, and we'll go down here. And we want to set these values to be something a little bit more reasonable. So we will, let's see, we'll keep her open in here so we can constantly look back and check. We'll start out by setting depth offset, distortion strength, emissive intensity, extrusion height, mask height, and then now that's everything. And we want to set our emissive intensity to be higher. We want to set our distortion strength to be 0.02 instead of, yeah, so set the distortion strength to 0.02, set the emissive intensity to, let's see, what did we set it for the footstep 001? 775, okay. So set our, so keep our depth offset at 0.9, set our distortion strength to 0.02, set our emissive intensity to 775, make it really bright, set our mask height, set our extrusion height to be 3, and then set our mask height to be a lot higher, something like 66. That way we're seeing significantly less of the feet. Now if we go back, okay, cool. So now we're only seeing like the feet cut off instead of everything else. We're just about ready to test this out. We just need to change a few more things inside of our footsteps actor and then also in our VR teleport visualizer. First thing we're gonna do is go into the VR teleport visualizer, and we need to find the NS teleport ring and play area bounds. So we're gonna go into the NS teleport ring, and we're going to find the NS teleport ring scene component here, or like Niagara effect. We're just gonna go hidden in game because we don't need to see it, but we do need to know its location for, you know, different reasons. And now we'll close that, and we're gonna go into our BP footsteps AI, and we need to change the collision of this, otherwise it'll spawn off to the side and also kind of overlap with us, which is not what we want. So we're going to go into our BP footsteps AI, and also we're going to comment here, AI moves to jump location on spawn. And then we're going to go into our BP footsteps character, like class defaults. We're going to scroll all the way down to our collisions here, and right now yours is going to say like character class. You're going to change it from object type to actually pawn. From character to pawn, you're going to change its collision presets to custom, and we want it to overlap all. So we're just going to, right now it's set up like this, we're just going to click overlap all, so that way the mesh just walks over everything and doesn't collide with anything. And then we're going to scroll down to the actual capsule component, and we're going to have that you know, right now it's set to block as well. We're going to have that ignore everything except for world static objects. We want it to walk around like static level objects, but we don't want it to interact with anything else. So now we can compile and we can save that. And we're going to then go into our VR pawn again. And we're going to find this, let's see, where is it? Teleport trace Niagara system, and we're going to go over the right here where it says Niagara system asset. We're going to double click on that to open it up, and then we're going to go into the Niagara effect. And so we're not going to do too much in here. We're just going to change the color of this ribbon from a like kind of rainbowy to something that better matches our colors that we have in our current scene. So we're going to go to this color rainbow curve inside of the teleport color node, and we're going to double click on that. And we're just going to change it to this orange. So we just click on the color up here, change it to that kind of orangish color. And then at the end, we'll do like more of a like yellowish color. So there we go. That gives us this arc that's much more similar to the Half-Life Alyx look that we're going for. So we can save and quit that as well. And then we can go ahead and test out our teleport system. As you can see, we have a better arc. We have footsteps that walk from us to the teleport location. So if I'm holding this and I want to move it, the footsteps will go and follow that object and then disappear. Then when I teleport, they go away. And then if I am having my footsteps spawn and I want to teleport, there they go. So that is basically the Half-Life Alyx system. One more thing that I think this could use visually is kind of that like glow that we see in Half-Life Alyx when you're pulling back the teleport. You can kind of see this like oval of glow on the ground where the footsteps that you want to teleport to are. And I think that looks really good, and I think that we should create something very similar. And it's a really simple material that we can use for a lot of different things. I think we're going to try and put that together right now because I feel like it would be useful. So we're going to go into our VR template materials folder again, and we're going to right click and we're going to create a new material, and we're going to call this one M_blob shadow. All right. And we're going to open that up and dock it up top here. And what we're going to do with this is we're going to create that glow sphere on the ground, and I'll show you exactly how to do it. So first things first, we're going to click on the master asset here. We're going to go over to our blend mode. We're going to change that to translucent. And then we're going to change the shading model to unlit. Since this is technically a shadow, it does not need to have lights on it. Then we're going to go over to the top here. We're going to hold down V and click to create a vertex color parameter. And we're going to call this one shadow color. Now, if you wanted to, you could leave this black and use it as like, you know, to create shadows for different objects, or the character itself if you wanted them to have like a blob shadow. It's a really inexpensive way to do shadows, and we've been using blob shadows for VR games for years now, but we can also use it for cool visual effects like this. So let's go and grab the same color that we set our holographic material to, like a little bit of this like kind of cool glowy yellow. And then we're going to drag off of this shadow color vertex parameter. We're going to do a multiply node, and we're going to create a scalar parameter, and we're going to call this glow intensity. And we're just going to leave this at 0 for now, and we'll change it inside of the actual material parameter. So we will go ahead and do that right here. And we'll drag this from the multiply directly into the emissive color. And now we can create our opacity. And this is where the blob shadowy shadow part comes in. So what we're going to do is we're going to create a world position behind world. Nope, not an absolute world position. Sorry. We're going to right click and we're going to do world position behind translucency. Leave these as so, pull off and do a subtract. And then we're going to do an object position. And this will be world space. Absolute, yep. And then we're going to drag off of that and create a sphere mask. And that's going to give us that like ovular shape that we want, sphere mask. And we need to just put a value into the B, and to do that we're going to hold down 1 on the keyboard and then click to create a constant, like a linear constant, and we're going to leave that at 0. And for the radius, we want to be able to kind of directly control this inside of the material instance. So what we're going to do is we're going to create a scalar parameter by holding S, and we're going to call this one radius, and then we're going to create another one directly beneath it by holding S and clicking, and this one will be hardness. And we'll plug in the radius to radius and hardness to hardness. And for the default value on the radius, we'll do a 50. And for the hardness, we will do a 1. And then we're going to pull off of that sphere mask. We're going to create a multiply node. And for that, we'll create a opacity scalar parameter. So we'll do opacity. So just hold S, create a scalar parameter, and then type in opacity. Change that to 0.4 because it's a really good middle ground. Drag that into the multiply, and then we can just connect this straight up into the opacity of our material and apply and save. Now, it's not gonna look like anything right now because you can't really see it inside the material editor. We actually need to add it to our character itself. So what we're gonna do is we're gonna go to our VR template again. We're gonna go to blueprints. We're gonna find the Half-Life Alyx jump material, or jump blueprint. We're gonna go into the viewport, and we're going to grab the feet mesh, and we're gonna add a cube. Just like a standard cube. And then we're gonna go down to collision, and we're gonna make sure that this is not, it doesn't have collision. We're gonna set it to no collision. We're gonna set the character to not be able to step up on it, and it does not generate overlap events. And then we're going to go up here, and we're gonna change this basic shape material to our, actually. We're going to go to our materials again. We're gonna find our blob shadow material. We're gonna right click on that. We're gonna create a material instance. And then we're going to change that name from m_blob shadow to mi_blob shadow. And we're gonna open this up because we're gonna need it. So we'll go here and grab that blob shadow material and save it. We're gonna go back into our BP Alyx jump. We're going to set the basic shape to our blob shadow, mi, and make sure it's the master material, the material instance, not the master. So you can see it makes that cube invisible. And in order to see this better while we mess around with these settings, we're going to press this little browse icon in the upper left corner here to find the asset, and we're gonna drag it into the map. And as you can see here, the shadow looks like this right now. It's just like a standard circle. We're gonna go into our blob shadow here. And we want to change we want to activate all of these because we're going to change all of them. We'll change the glow intensity to something around 10. We will change the hardness to something really low, like 0.01. That's how harsh the edges are on our blob shadow. We're going to change the opacity to 0.02. And then we're going to change the radius from 50 to 30 so it's a little bit smaller and more manageable. And then we're going to save that, and we're going to go back to the map, and look at that. We've got that super cool glow on there. That looks pretty good. And if you look, it's kind of off center, so we'll go into our blueprint again. We'll move this forward slightly, and we'll compile and save that. And that looks a lot better. I think that we could actually probably bump the opacity up a little bit more, so we'll do 0.1. And we'll take a look at that. Yeah, that looks a lot better. Okay, so now we will close this material editor. We'll close the Half-Life Alyx jump. And then we will delete this actor out of our level because he's not necessary. All right, and let's see how that looks in VR. All right, so grab our controllers here, pull back on the stick, and look at that. So you can mess around with that blob shadow material and make it look however you want, but this is pretty much what we have for the visual effects on the Half-Life Alyx jump mechanic. And yeah, that looks pretty good. And then of course we jump forward. I think that's a really solid, thing, and we've got a lot of material parameters there, so you can tweak it to, fit however you want. So we've accomplished a lot in this tutorial, and I want to go through everything. So here is what we've accomplished in this tutorial. We have successful strafing and forward and backwards movement. We have snap turning on the right hand. We have the Half-Life Alyx jump with animations. And then we also have the ability to walk around with objects. In my opinion, that's a pretty successful tutorial. That wraps up my VR locomotion tutorial. I hope you found it both useful and informative. I'm working hard to improve how I explain the code as we write it together, so your feedback means a lot. If this video helped you, please consider leaving a like and subscribing to the channel. It really helps me out. These videos take a lot of time to create, and your support makes a big difference in helping them reach more people. This video is part of my Rebuilding Half-Life Alyx in Unreal Engine 5 series. In the next video, I'll be teaching you how to add physics interactions to the VR hands, followed by creating an inventory and weapons system. Don't forget to check out my previous tutorial on adding procedural grip poses to the VR pawn. It'll be valuable for the upcoming lessons. Thank you so much for watching, and happy developing.